Hey everyone, today we're going to be looking at properties. Don't forget, you have a graphic organizer which quite nicely follows along with my lecture slides today. So property classifications, let's go ahead and get into it. What the heck are properties? Well, properties are going to be any sort of characteristic or attribute of a substance, of a chemical. They are how we describe that substance. There are four main types of properties that we're going to be looking at today: chemical, physical, intensive, or extensive. Um, Chemical and physical are going to be exclusive from each other. So when you're studying a property of a substance, it either is chemical or physical. Intensive and extensive are exclusive from each other as well. So a substance will either have extensive or intensive properties. So with that being said, let's go ahead and jump into physical properties. When we're looking at physical properties, it's important for us to understand that the identity of the substance does not change when that observation occurs. Essentially, the chemical formula, the chemical makeup stays constant. It stays the same. And along those lines, if we were to go ahead and look at the physical change is going to be when the matter undergoes some sort of change to its physical appearance, but not its identity. So the formula, the chemical, all the chemical bonds stay the same when a physical change occurs. A really common and good example of changes of state, physical changes are changes of state. Changes in state are characterized as physical changes. Examples of this are going to be when we go from a solid to a liquid or a liquid to a gas. Us being in AP chemistry, you should be very comfortable with the definitions of melting, freezing, evaporating, and condensing. The arrows indicate the direction you must go in order to do that thing. So, for example, if I change from a liquid to a gas, I am evaporating. The other examples, which are less common in the natural world, but still fairly common in the chemistry world, are going to be sublimation and deposition, or when a substance sublimes, or when it deposits. Solids changing directly into a gas is called sublimation. Gas converting or changing directly to a solid is called deposition. Good examples of this would be like dry ice. Dry ice does not exist as a liquid under atmospheric conditions. So when we go ahead and have dry ice, it immediately turns into the gas phase. It sublimes. As far as chemical properties goes, the identity of the substance does change. Chemical properties refer to the ability for a chemical to react. Oftentimes, we'll say something along the lines of copper, as we see in our penny example over on the left-hand side, reacts with nitric acid. This produces a beautiful blue copper nitrate solution along with nitrogen dioxide, which is the brown gas above. Chemical properties, once again, refer to how chemicals change their identity. A chemical change is specifically known as a chemical reaction. Pretty much exclusively after this point, I'll call chemical changes chemical reactions. This is going to be when one or more substance changes into one or more different substance. Now, moving on to extensive and intensive properties. When we're looking at extensive properties, we're looking at a characteristic that depends on the amount of stuff that you have. What I'm talking about is going to be, for example, mass and volume. If I were to have, like, let's say, a pile of gold, and I were to double the pile of gold, make it even bigger, the mass would increase. The property, mass, is dependent on how much stuff I have. The same goes for volume, the same goes for internal energy. The example I like to use for internal energy is that if I were to have a full tank of gas versus a half tank of gas, I could get further, right? If I had more gas, I could get further in my car than if I had a half tank of gas. Extensive properties depend on the amount of stuff that's present. Conversely, we have intensive properties. Intensive properties do not depend on the amount of matter. My example that I like using is boiling of water. Water will always boil, pure water will always boil at 100 degrees Celsius. If I had a cup of water, if I had a bathtub full of water, the boiling point will always stay the same. Melting point is another example of an intensive property. And density for solid substances at a specific temperature is also an intensive property. We love intensive properties in the world of AP chemistry because we can use these to help us identify unknown substances. That's it for today. Thank you so very much.